Okay, today we're going to talk about a very interesting algorithm called quicksort. Which was invented by Tony Hoare in 1962. Okay? And it has ended up being a really interesting algorithm from many points of view. And because of that, it turns out today's lecture is going to be both hard and fast. Okay, so everybody, if you didn't, if you see the person next to you sleeping, you'll want to say, let's get going. So it's a divide and conquer algorithm. And it sorts, as they say, in place, meaning that it just rearranges the elements where they are. So that's like insertion sort rearranges elements where they are. Merge sort does not. Merge sort requires extra storage in order to do the merge operation. Okay? To merge in linear time in place, it doesn't merge in place in linear time. It doesn't do it just by rearranging. So it's nice because it's in place, so that means that it's fairly efficient in its use of storage. And it also happens to be very practical. Okay, if you tune it a bit. Okay, the basic algorithm turns out if you just implement that, it's not necessarily that efficient, but if what you do is then do the standard kinds of things you do to goose up the runtime of something, and we'll talk a little bit about what those things are, then it can be very, very practical. So it uses divide and conquer paradigm. And so first step is divide. And to do this, basically it does it by partitioning. So it partitions the array, the input array, into two subarrays around an element we call the pivot, such that elements in the lower subarray are less than or equal to x or less than or equal to elements in the upper subarray. So if we draw a picture, of the input array, so this partition step basically takes some element x, and everything over here is less than or equal to x after the partition step, and everything over here is greater than or equal to x. Okay? And so now the conquer step is pretty easy. You just recursively sort the two subarrays. So I recursively sort the elements less than or equal to x. I recursively sort the elements greater than or equal to x. Okay? And then combine is then just trivial, because once I've sorted the things less than or equal to x and sorted the things greater than or equal to x, the whole thing is sorted. Okay, so there's nothing to do really for the combine. So the key step in quicksort is this partition step. So that's the thing that that does all of the work. And so you can view quicksort as just recursive partitioning. That's all it is. Okay, just as merge sort was recursive merging, Okay? Quicksort sort of goes the other way around and does recursive partitioning. So the key is the linear time, by which I mean theta n,